know that you've been doing a lot of work in developing bamboo as, I guess, a non-traditional building material. But
Mhm.
I'm curious, how did you get interested in just non-traditional building materials as a whole? I guess, were you interested in those, or were you interested in bamboo? Where did you come in? Where did you enter this
Yeah, so
story?
so my career in researching materials and products from unusual materials has, been going on for over 20 years now. And I really have like two interests that coalesced in the bamboo work, but really there's a third larger one, which is really just craft or materiality. So, I've been exploring materials in a way that I would say is about eccentricity for much longer than just the natural materials. I'm actually trained as a metalsmith. I have a master's degree in metalsmithing, and I was a professional blacksmith for about 4 years before all of this. And I bring that kind of toolbox metaphorically and literally to the work with bamboo, displacing, moving, braiding, placing, machining materials to find new and different ways to use them is something that I've been doing, through all the work that I've done creatively since I started making things, more or less in college as an artist.
Well, I read somewhere that part of your story involved maybe you in some landfills looking for materials.
Yeah. So when I moved to LA after college and started a kind of design and build company, mostly doing architectural metalwork and some other kinds of architectural design and fabrication projects, and also with the eventual hopes of starting a furniture company. And I was looking for like the right, let's say, hook or the right reason. And for me, I was really interested in sustainability. This is right as green building standards were being launched in the United States, and bamboo flooring was being imported, and cork was suddenly a kind of hot material. And I was interested in thinking, well, are there any local materials within my own, kind of daily life that are cast off or wasted? And I started, researching palm because palms are really common grass ornamentally in Southern California. And it turned out that all the palm in Southern California, it's still true to this day, gets weeded out of the green waste stream and sent to landfill. And so that's kind of how I got interested in grasses, was developing composite furniture and composite kind of sample boards out of this, waste material that was being weeded out of landfill. It was going to the green waste facility, and they were weeding it out of green waste and diverting it to the landfill because farmers would not accept mulch that had palm in it. So it was one of the, probably not as big as grass, as ornamental grass that your turf, so to speak, but pretty close as a quantity of material that, in Southern California, there's a lot of palm fronds that are pruned and cleaned up of trees to reduce fire risk and to reduce, rat infestation and those kinds of things. And all that material was just going to the landfill. And this was 20 years ago or more. It was something like $50 a ton just to dump it. And I'm like, well, that's a resource. Maybe we could make something out of it. And that's kind of how this work in some very vague sense started.
Do you know why the farmers didn't want it in the mulch?
Yeah, because when palm is ground up, there's still seeds in the grass. Palm's also a grass like bamboo, and most seeds don't germinate at really high temperatures. And piles of mulch, they get to be hot enough to actually flash on fire sometimes, right? There's
Yeah.
just a lot of heat in that kind of biological material under the sun, and also as it kind of goes through a kind of chemical transition as it biodegrades. Well, when that happens and you sprout a palm tree, and you're a farmer and you're trying to, raise a crop, you're not happy about it because you're trying to cover the land so that you don't have things growing other than your crop. And now you have like another pest popping up. So they basically wouldn't accept palm in the material they would accept. Farmers were the major consumers of municipal green waste in
Yeah.
California. I don't know if it's still true today, that part of it, but it was true, 20 or so years ago.
Yeah, that's really interesting. Well, how then did you get involved with bamboo?
Sure. So I had worked a little bit with bamboo when I had a furniture company. The furniture company was indirectly related to the palm research, and I got involved with bamboo when I started teaching a class at VT. The class is I still teach it, is Materials and Processes of Industrial Design, and in that course I talk about wood, and I talk about plastic, and I talk about, a bunch of different metals and glass and all the basic materials that we make products out of. And when I was developing the lecture on wood, I thought, I don't really want to take any material position with any material that is standard and just sort of assume that the standard way of thinking is how our students should have their minds shaped about materials and process. Instead, I want them to think that they should be alchemists in a way and be really thinking about what are the sources of materials? How do we convert those sources into things that are appropriate for our needs? And could those things come from other sources that are not the ones we would immediately assume? And so, I thought about palm, and palm's not necessarily a practical material. There's no one else, in my knowledge, no one's ever manufactured a wood-like composite outside of my little mad science laboratory in Los Angeles. But bamboo, many people have made into wood-like material, and it already is a wood-like material from the get-go. And so I thought, well, that would be an interesting material to bring into the mix. And so I developed a lecture on grasses. It covered some of my research. It covered palm and rattan and bamboo, and then I also covered wood in the next lecture. And it just got me curious about bamboo. And I really was looking for something to research at that time. It's when I first came to tech. And I was looking for materials. Some of it were biological and some of them were technical. Technical meaning things like plastics that could be recycled. And I wanted to think about how to, to better use or better increase utilization of materials through design and through innovation. And so that's kind of how the bamboo, kind of thing came out of this interest in palm and then out of a teaching effort.
Yeah. And so now you are working with this material and trying to figure out how to make buildings out of it, create buildings out of it in Ecuador. And so I'm curious about so much about this project, but I guess maybe to set the stage for that, what is the housing situation like in Ecuador?
Yeah, so I would prefer to talk about housing with a global lens because
Okay.
I'm not an expert on any of these numbers. But what I would say is that in most developing countries, Ecuador, would be very much included in this. Most countries within the kind of the geography that is near the equator, some call it the global south, but some don't like that term. So I'll say the area near the equator where countries are developing. There is definitely a shortage of housing, and there's definitely a heavy reliance on concrete and steel. And both,
Okay.
and we also know that those materials are, they cause, they're contributors to greenhouse gas emissions, to global warming, and they're also expensive over time. Presently, in a place like Ecuador, it's definitely cheaper to make a cement building than a fancy bamboo building. But if bamboo was utilized in the right way, bamboo theoretically should cost less. The material is self-regenerating. You don't have to heat it to 800 degrees to get the kind of chemical reaction to happen. And then even hotter when you're, refining the different elements. So there's a lot of like processing for steel or for cement that bamboo doesn't have to go through. And so that's what kind of has led us to think that bamboo might be a good replacement. And there is a bamboo culture in Colombia and Ecuador and has been for hundreds of years, if not more. So there has been housing made in bamboo for a very long time, just very informal housing and not necessarily housing that could urbanize. So that's what we're doing is really looking at, could bamboo be an urban material solution for construction in, I'll use the term the global south, where it grows, where it's often abundant, and where it's often underutilized?
Okay. So something that could be developed and maybe scaled up for a lot of to help house a lot of people. I
Right. But
guess what it
also,
sounds.
when we say scaled up, I mean in both senses of the word. Scaled up meaning making lots of units of housing, but also scaled up and making housing that is urban and can go to multiple stories. So making 1 or 2 story low rise housing, there is a need for that in nearly every country, including developing countries. But there's also a tremendous need for urban housing, and the 2 billion more households that will be needed by 2050. They're mostly going to be in urban areas and hot climates. And so this set of conditions that is developing, the globe is warming. We know that these hot places have these tropical resources like bamboo. We know that their populations are growing faster than they're growing in developed countries. And so if we're going to meet those housing needs without further contributing to greenhouse gas emissions, we have to get off of concrete and steel. And so bamboo becomes a really interesting possibility.
Yeah, so scaled up in many different ways. I like that. I like that. I like being able to use words in multiple ways as a writer. Well, what are some challenges to working with bamboo in the sense of what you're trying to do?
Sure. So on the good side, it grows really fast and it's abundant where it grows and it self regenerates. But on the bad side, if you compare it to, let's compare it first to wood just for one moment and say,
Yeah.
so when you use timber in construction, you take a big tree trunk and you mill it into boards, and every board is kind of the same. Not exactly the same in a really finite sense, but more or less the same. You call it a 2x4 for a reason because it's roughly, in a rough sawn form, 2 inches by 4 inches,
It should be.
and it comes 8 feet long, right? And that quality of a unit of material, bamboo cannot be reduced to in a very easy way. So you can make a fiber out of bamboo or a very small little rectanguloid, a little tiny slat. But if you want to make anything the size of a 2x4, it's probably going to come from a round bamboo or lots of little pieces. And this causes a problem on both sides. If it's round bamboo, now every single piece is different, which means to get pieces that are similar, you have to weed through a lot of material. And that means you're probably going to be wasting material. On the other side, if you turn it into a fiber, you're either going to use a lot of glue because you're going to make it into a fiber that's more like spaghetti. It's what's called strand woven bamboo. Or you're going to make it into these like little rectanguloids that you glue together like a butcher block. And when you do that, you lose at least 60% of the biomass from the standing bamboo, if not more. So there's a tremendous amount of loss in either scenario. And so bamboo, although a standing column of bamboo in most countries is maybe $2, pay a farmer $2 or $3 US dollars to cut one down. It's a 100-foot tall piece of material that has at least 60 foot of usable material in it. But once you treat it, and then once you kind of select the pieces of it you're going to use for the construction or for the composite material, you're down to using 1/3 of it. So you paid $2 for it. Now once it's into 6-meter pieces that are chemically treated, now it's maybe $10 a piece. And if you compare that to a 2x4, it's actually more expensive than a 2x4, even though the raw material isn't, right? But if you could get every bit of that linear material that you cut down, let's say it's 80 feet or even 70 feet that might be useful, into the product, not just into the factory, but into the final product, then bamboo becomes possibly more viable. So bamboo has been too expensive. That's been the biggest problem, is that really to industrialize bamboo, you have to get the cost down. And to do that, you have to be more efficient.
Well, how are you going about maybe tackling that challenge? What are some things that you're working on to address it?
So we've developed, at Virginia Tech, we've developed, collaboration mainly between Dan Hyman from the S Bio department and me from industrial design. We've developed a material system that starts with, so first off, we're trying to develop a system for mid-rise housing. So the system I'm talking about is that whole system, a building system to make housing. But when you go down, so that's the top scale of the let's say the design or the invention we're trying to work towards. The very bottom scale of that invention is what I would call LMB, or lightly modified bamboo. And that's a bamboo element that we've either in a regional sense, somewhere along its length, we've made a very accurate change to its shape, meaning we've like surfaced it flat, or it may be the whole length of usable material that we're making flat. So we're taking a round hollow thing and we're putting at least regions or sides onto it that are flat. And when we do that, now, even though it's not exactly the same every piece, at least its width can be exactly the same. And so we have a material that can now be turned into things like a wall or a floor or a beam because we have uniformity, at least in one direction. And so
What
that's our major thesis, is if we lightly modify bamboo, we can make it predictable. If we make it predictable, we can turn it into composite material systems, and those systems can make up walls, floors, and beams. And the walls may be structural or non-structural, interior or not interior. And the beams can be used to make floors directly as the main kind of system, or to augment the panels, it can also become floors.
what are you using to modify them and make them more uniform?
So we've built a series of different machine prototypes and also hacked a bunch of machines, old woodworking machines, and we rip or saw cut with a round blade 1 or 2 flat sides onto lengths of bamboo that could be as short as 4 feet long or as long as about 12 feet long. And in some cases, we then use other conventional woodworking processes to hone those surfaces flatter. In other cases, we make elements for the beams, we make elements that are actually tapered, and those elements we make it a different way using conventional hand woodworking tools.
Have you figured out how to maximize the use of one piece of bamboo? Like you mentioned earlier, you're only able to use so
Yes,
much of it.
I would say theoretically we have, and we've also
Mm.
developed some scanning tools and the beginnings of algorithms to kind of sort and place and identify where to put bamboo into the building. So the big notion is if you can lightly modify it, but if you also can identify a structural need that's specific and maybe even highly specific, and place the bamboo exactly where its maximum safe capacity can be leveraged, then you get to a high utilization position. And that's something that with steel buildings, you do a little bit of this. With concrete, you do a lot of it. But with wood, you can't do all that much of it because the wood is coming set sizes. Bamboo can't be set sizes very easily. So with bamboo, there may be more, it's more, maybe a little bit more complicated and expensive to get there, but it's more logical that you would try because you want to make use of this material that otherwise, has to be cast off in your process. So in other words, like the walls on the third story of the building may not be the same thickness as the walls on the first and second story because the third story is not carrying the load of the first and second story. And therefore, in compression, those walls may not need to be as robust. So if they don't have to be, why not use a different part of the bamboo to make them so we can use more of the bamboo,
Yeah.
not privilege certain cuts?
How far along are you all in this process? Have you built like a single story or a double story
We
building?
haven't made any full buildings yet, but we've floors. We've done enough testing on the bending capacity to feel confident enough to do things like build the floor of an office in the factory that we're collaborating with in the Philippines, or in Ecuador to build a small cabin with students as a research project. Now, that building doesn't have a building permit, is not meant to be lived in. It's just an early test. So we are making some buildings, but we're still waiting on more development, but in most cases, more testing. We have another round or two of testing to do before we can be really confident that what we have is safe and reliable.
Yeah, that makes a lot of sense to me. Well, if this is successful and you are able to scale this up into multiple ways, what do you think that some possible ripple effects might be from being able to use bamboo in this way?
I mean, I'm humble enough to know that we may not be successful, but there's been a handful of companies that have gotten really far, for example, into the US market or the global market, but almost always at some point they fail to really unlock bamboo's potential. And so what we're really after, so on the one hand, we're after kind of the product of this building we're trying to develop, for these different markets, mainly in Ecuador, but other markets as well. But we're also after, as researchers, we're after really unlocking bamboo's potential to serve humanity's needs in a symbiotic way. So right now, bamboo is way underutilized, and these other materials are very much utilized. And we know that they're doing real harm to the environment. And bamboo could be a real climate change maker because, it's great at warehousing carbon, it self regenerates, and it displaces these other materials. So if we're successful, we hope to be making a model for how buildings of the future can be made in a way that is really lighter on the land and more sympathetic to being part of of an ecosystem that we are only one member of, not the head member of.
Do you want to live in a bamboo house one day? Like, was that something you're like, yeah, that'd be kind of
Yeah, I
awesome?
mean, I think there's a small chance in the United States I'd like to live in a bamboo house.
Yeah.
In other words, I'm not quite sure yet that the business model makes sense to do this for the United States. But certainly when I have my satellite residence somewhere else in the world, in one of these bamboo countries, which I would love to have someday soon, without a doubt it'll be a bamboo house, and without a doubt it'll be a bamboo house made from composite, lightly modified bamboo.